So, how many people were here for the last talk I gave last year about Kubernetes and some network policy? Okay, so most might be a little bit of a repeat, but what I do want to talk about here is a little bit of deploying network policy, and by that I mean Kubernetes or Kubernetes-like network policy in a hybrid environment. And hybrid environment actually has some interesting definitions as to what we mean by hybrid, so I'll talk about a couple different cases. How many people here use Kubernetes network policy today or are familiar with it? Excellent, okay. So, my engineering VP. So I'm Christopher Liljenstolpe. I'm the CTO and co-founder for Tigera, the original architect behind Project Calico, and my VP of engineering pleaded with me to put that up. So if anyone's looking, we'd love to talk to you. So I'm CTO for solutions here at Tigera. Been doing this for a while. Who is Tigera? I should probably get out of the way here. Large cloud, we're basically the home of Calico, Project Calico, the open source project. And I'm trying to figure out where to stand so I don't block people. Maybe over here. We have out-of-the-box support for Kubernetes, and then we have commercial products for large-scale enterprises. For the things that have changed maybe since we last talked, we are now the network policy agent underlying Google's hosted Kubernetes offering GKE, EKS, AKS, and IBM public cloud Kubernetes. So if you use hosted Kubernetes on any of those platforms, you're already using Project Calico. You already have the ability to do network policy. Just flip it on. Actually, everything but Azure AKS, that's going to drop like within the next couple of weeks. They missed their first release of AKS, but it's, for all intents and purposes, it's there. Application development, we've talked about microservices already today, so I won't spend too much time on this, but we take microservices, we make them very dynamic by running through something like Kubernetes. We deploy them in elastic cloud infrastructure and using containers. This creates some interesting problems with the way we've done network isolation to date. The elastic cloud infrastructure is also sort of interesting in that today I might be deploying it in private cloud in my own infrastructure. Tomorrow I might deploy it in AWS. I then get my CIO goes out and plays golf with someone from Azure, and the next thing I know we're using Azure public cloud, and I got to move all my stuff over to Azure public cloud. That's never happened before, right? I've been through that. I know it's fun. So we need to be able to create a platform that supports all of this dynamicism. We're much more dynamic than we used to be. Some of the dynamicism, containers have much shorter start time. Takes 900 times X, usually less time to start a container than a VM. You get about 15 times more workloads on a server. How many people here are you, for the folks who are using Kubernetes, how many pods average per host? North of 50? North of 100? North of 200? Got one person trying to push 1,000 onto each server. They had a bunch of VM machines, so they had 48 core machines, so they're trying to cram about 1,000 containers per VM, and I talked to them about blast radius. It's Kubernetes now going to have to find a home for all 1,000 of those homeless children if that server goes bye-bye. They live much shorter lifetimes. Containers last inherently shorter lifetimes if the reason we're deploying Kubernetes and microservices is to get to a rapid development cycle, which is what most people are doing it. So we have a much larger attack surface and we have much higher churn rates. So some of the things we need to think about as we're deploying these environments, how do we do stage and tier separation? Today we do that. One VLAN or one cluster is dev, one is prod, one is QA. Tenant or namespace isolation, Coke versus Pepsi, or public markets versus personal wealth if you're an investment bank, etc. Microsegmentation. Perimeter firewalls don't really work anymore, guys. Ask Experian, ask anyone else. Once somebody gets inside your infrastructure, if they can run everywhere, you draw this nice little wall and say, it's a cordon sanitaire and everything inside is trusted. There are two types of organizations in the world, those that know they have an advanced persistent threat internally and those that don't. If somebody gets in and they can then walk your organization, map everything out, and hopefully they tell you as they're exfiltrating it out, but they don't. So segmenting it so that if you know that the only thing that these front ends should be able to talk to is these back ends, being able to state that these front ends should only be able to talk to these back ends is probably a good idea. That way if someone pops the front end, the most thing they can do is talk to the back end on the protocol that you've specified for the back end, which of course you've already done all the things to harden that protocol correctly, right? So no one can do injection or something else across that protocol. And continuous compliance. How many people here are in environments where they have to meet compliance, regulation requirements, PCI, etc.? How many people do that via compliance audits? So if I audit 4 times a year, and I'm deploying new code every 15 minutes or 4 times a day, how long was that compliance audit report good for? It's sort of like a broken watch. You're in compliance you can state you're in compliance 4 times a year. So you need to start thinking about how you continually measure compliance in your infrastructure. Some of the things we're going to talk a little bit about policy. Actually, this slide I meant to strike out, but since it's here, it's here. One of the things we do at Tigera, for those of you who are familiar with Kubernetes network policy, we allow you to create tiers of policies. So now the compliance team, for example, can write a policy tier that is independent and takes precedence, say, over the developer tiers. So now instead of having firewall rule changes when we make a I deploy my code in 5 minutes, it takes me 2 weeks to get a firewall rule update. People are giggling. More, less. World record I've heard so far is 4 months to get a firewall rule change. So, and that happens because all of these teams need to check every rule that you put in the infrastructure to make sure that it's not going to bork their requirements. But instead, if I can say to the InfoSec folks that your PCI policies will get acted on independent of whatever the developers say or anyone else says, then they don't need to check all the policies that are being deployed, all the micro-segmentation that's being deployed by the developers. Because the PCI policy takes precedence. Things not labeled PCI can't talk to things that are PCI contaminated. So you also now increase your ability. They don't have to vet all those rules. It makes for much faster deployment scales. Let's talk a little bit. I'm trying to cram a lot of stuff into 20 minutes, guys. So when we start thinking about policies, network policies, so Kubernetes network policy, for those of you who aren't aware of it, is something along the lines of things labeled Bob can talk to things labeled Alice on 443. And then whatever Kubernetes labels, whatever workloads have Kubernetes labeled Bob on it, we'll be able to send 443 traffic to anything labeled Alice. And similarly, Alice could have the reverse policy. It says anything labeled Bob can send things, Alice will receive traffic from anything labeled Bob. So Kubernetes is driven by labels. So you can start writing those policies. What you need to start thinking about is that policy should be composable. You shouldn't make, how many people here write a firewall rule, a single monolithic firewall rule per application? Like this application, this IP address has all of these things that can be talked to it and communicate from it. And that's sort of handcrafted for each little micro group of applications. Really hard to manage. Let's think about policies more in terms of behaviors or personalities. LDAP clients should be able to talk to LDAP servers. Things that need to log should be able to talk to syslog servers. Application A data front end should be able to talk to application A, or back end should be able to talk to application A databases. So you start thinking about policies as composable objects, and then workloads get identified with what their personality or their state is by labels. And one or more policies will then can be attracted to that workload. So if this thing is a stage dev and it's running in Europe and it is a LDAP client, then you might have a policy that says Things running in Europe can't talk to things running in the United States. We're rapidly approaching that. So that might be a policy that's in there. So that means that any European workload will be prevented from talking to anything in the US. LDAP clients should be able to talk to LDAP servers. Things that are stage dev should only be able to talk to things labeled stage dev, not to stage prod. So a workload that's an LDAP client in Europe that is in stage dev would only be able to talk to stage dev LDAP servers also in Europe. But instead of making one monolithic policy, you now have these much more role-based or state-based policies, and a number of them might accumulate onto a given workload. That way you don't have to, okay, we've now changed and we now need to allow access to this other piece of infrastructure. I now need to remember where all the policies, all the workloads that have a policy that need to be updated like that. It's probably not, you're going to miss one. I'll guarantee you're going to miss one. So if you do it simply with labels, and labels identify the role or the state or whatever else you might think about as a labeling terminology, then you just create a new policy, and that policy automatically gets deployed everywhere else. So let's talk about this from terms of a PCI compliance environment. You need to build and maintain a secure network. You need to protect cardholder data, hopefully. You need to maintain a vulnerability management program, implement strong access control, monitor and test networks, and maintain information security policy. Your CEO and your CIO wants to make sure it scales, it's performant, it doesn't cost an arm and a leg, it's agile and has security. So how do we mix these two together? So we could start the old way. We have a cluster, we have a VLAN that's PCI and a VLAN that's not PCI. Great. It's one way of doing it. How many people do that today? Here, for given compliance. Okay. And then you just make sure that PCI can't talk to non-PCI. That works. Now let's go to Kubernetes. Kubernetes has a concept of workers, and it sort of doesn't really care what workers are, right? It just plants, unless you use taints and in case you use tainting systems, basically any workload ends up anywhere. So if you want to keep the same model, you have to do taints, and you have to say this worker will only handle PCI traffic, PCI workloads. Other workers will handle non-PCI workloads. And then you build firewalls around those workers. That's great. You know, that's basically you've just replicated 30 years worth of technology in your brand new, bright and shiny Kubernetes infrastructure. Good on you. A little problem, new PCI workload comes along, the only worker that's able to doing PCI can't handle this workload. I've got spare capacity, but that spare capacity is not consumable because it's a PCI workload. So if I've done this as a perimeter in Kubernetes around a node or whatever, this is going to be somewhat problematic. What if instead, using network policy, I build the filters right around the individual workloads? The workers no longer have any state. They're just hosts. They're just nodes on the network that host containers or pods. And now we do our filtering right in front of the workload. This is the basis behind Kubernetes network policy. And now I can have a PCI workload with a whole bunch of other non-PCI workloads, but PCI can't talk to non-PCI. The policy on this workload will say the only things it can talk to are these workloads over here, not all these others. So now policy follows the workload. It doesn't matter. This thing dies, and Kubernetes spins up its replacement over here, or it scales it out to 10 other hosts. Those policies are automatically applied to that workload wherever it ends up. And everything else in the system knows where that workload went to. So this is, I think, sort of cool. Basically now Kubernetes is just a substrate, and the compute platforms are just a substrate to put workloads on. And the way this is done is there's labels on there that say those workloads PCI false. And you have a policy that says workloads labeled PCI true can't talk to workloads labeled PCI false. So what does this look like? You have a network policy. It may run in a namespace. It may run cross-sell namespaces if you're using Calico. It basically says any workload that's labeled PCI true, this policy will apply to. And that policy says, on ingress, I'm going to allow traffic, but only from things labeled PCI true, and on egress, only to things labeled PCI true, and I could further put port numbers, etc. on that. Some other things I can do with that pretty cool as well. So this means PCI can talk to PCI, but PCI can't talk to non-PCI because this policy has been applied to the things labeled PCI. Make sense? Easy? And I just walked through what those components are. There's some other interesting things we can do with Project Calico. It's now been released in the latest version of Project Calico, open source. I can now, if you're using Istio, I can now say that things labeled app details, for example, or anything else, PCI true, can only receive traffic from service accounts with the name product page. If you know what service accounts are in Kubernetes, this is an RBAC controlled label, so to speak. In Istio, this also drives the granting of a TLS certificate. So what this artifact actually means that anything labeled app details will only allow traffic in if it's TLS encrypted with a certificate attached to the service account product page. So you've now just enforced TLS security in the same policy. I can also have and selector labeled Bob, and then would only accept it if it was Bob and had a service account. And those are enforced at different points in the infrastructure. So even if you have a compromise and one of them gets taken out, the other one still holds. We can have groups of service accounts. And we can, this is what I just said, it has to be labeled product page and has to come from a service account with label in the service account of reviews reader. So any service account with the label reviews reader in it and at product page. Otherwise, the magic won't happen. I can go one farther and the screen's too far down. We can then say, but you're only allowed to do gets on things labeled cust record with URIs prefaced by cust record. This is all done through Istio and Calico working together. So now it has to come from the right node, has to make the right URI calls, and has to have the right TLS certificates in one 15-line bit of YAML. How many people here today manage their WAF firewall rules in one place and their network firewall rules in another place? There's some nodding heads. I'm sure everyone always makes sure that those line up correctly, right? You never have a problem where, it doesn't quite always work. No one ever has that problem, right? Here it's all in one object. So this is a rule crash course on Kubernetes Network Policy++, which allows you to do everything up through layer 7. Now, talked about the policies already. I'll get past this. I already sort of talked about that. Where we enforce this in Project Calico, we enforce this with a cryptographic identity within Istio proxy within the pod, and at the network layer in the underlying host, not in the pod's namespace, and together tie that into this label-based policy model. So you can do enforcement at L3 network identity, cryptographic identity, L7 characteristics, etc. It's all pretty cool. And we enforce this policy in the pod, outside the pod, and at the host interface. And the host interface is an interesting one because normally Kubernetes Network Policy gets applied at the virtual Ethernet that connects the pod to the host. We can also drive Kubernetes Network Policy using Calico at the host physical interface. So one thing you can use is you can use now Kubernetes Network Policy to protect the control plane of Kubernetes itself and other things. Who is allowed to SSH into these hosts? For example, I want my NOC to SSH into this host. But how do I say what things are my NOC? In Calico, you can attach labels to IP addresses and IP CIDRs. So you can now say this range of addresses, which is not running your Calico network policy, will still have a label, NOCnet. And then you can have a policy for a pod or for the hosts or wherever else that says only things labeled NOCnet can send SSH traffic to my workers. So now let's start taking that a little bit further. I can deploy on the host interface. It's really, at this point, has nothing to do with Kubernetes. So now, what I can do is I can attach labels to bare metal hosts. Same Kubernetes labels. The only thing is, there's no Kubernetes orchestrator for bare metal. So you will have to make API calls or have Terraform or Chef or Puppet or whatever, make Terraform calls to attach labels to hosts, i.e. the IP addresses that the hosts have. You can even do it to a network set, which is down there, which is what I talked about earlier. If you install Calico on these hosts, let's say running a legacy database or whatever else, if you install Calico on that, then if I have a policy that says foo consumers can talk to foo producers, I don't care if foo consumer is a pod, an IP address, or a bare metal host or a VM. So you got legacy Oracle databases running in your Linux hosts. They're never going to see the light of Kubernetes day. You can stick labels on them and actually stick Calico in front of it and make it part of your Kubernetes security infrastructure. Going a little bit further, you can install this same Calico agent on a middle box, sitting in front of, say, your Exadata racks or your NetApp filers, which you're never going to be able to store anything on. And it will now act like a firewall, but it's a firewall that's fully aware of your Kubernetes labeling scheme and Kubernetes network policy. And this is one of the big things we see people have problems with. They go to Kubernetes, this is great, things are spinning up every 5 minutes, they got network policy going, this is all great, but I've still got that database over there that has a firewall in front of it, and I still have to spend 3 weeks waiting to get that firewall rule updated. In this case, a number of these techniques allow you to bring that in. So this is one form of hybridization. Bring this in. So, 1 minute, okay? That's one form of hybridization. The other one I want to talk about really quickly, 2 Kubernetes clusters. Bobs can talk to Alices, right? Well, it would be really handy if I've got a Bob over here in cluster 1, and I've got some Alices in cluster 1, but I've got some Alices in cluster 2 too. It'd be really handy to know if, for cluster 1 to know where Alices are. So, one of the things we can do, this is not Kubernetes Federation, this is Federation, this is part of our commercial product, so please forgive me for a second, but we can federate identity across Kubernetes clusters. So now your LDAP clients in cluster 1 and cluster 2 can be reached by the LDAP server in cluster 1. We also have implemented for AWS something a little bit different than this. We can now use security groups as labels in Kubernetes cluster, in Kubernetes security. So you can now say Kubernetes to date. If you wanted to have a couple of Kubernetes pods in your cluster access an RDS database, you have to allow your entire Kubernetes cluster to access your RDS database because security groups are tied to the host interfaces, not pods. We fixed that in AWS, so now you can attach a security group label to a pod, and we will make sure the security groups know where things are. So you can now say, these pods are a member of security group X, and security group X is allowed access to your RDS infrastructure, for example. Or S3 if you're using a VPN endpoint. And we can reverse that. We can say security groups are allowed to talk to pods, individual pods. So that's yet another form of hybridization. We're using native cloud services in your Kubernetes cluster. So now, the stuff we've done, you can have multiple Kubernetes clusters in a hybrid environment, and this could be private cloud, public cloud, hybrid. You can do hybrid where you have different types of workloads on different hosts, different types of hosts, bare metal, VMs, containers, etc., and even consuming your workloads in the given cloud infrastructures. You're using native cloud resources. So there's 3 types of hybridization. All of them can be tied. So now you just write a policy. Bob can talk to Alice with these characteristics. You don't care where Bob is, where Alice is, what Bob is, what Alice is. You have a common policy across your entire infrastructure. That's a little bit about extending network policy into hybrid environments, whichever you want to define a hybrid environment is. All right.